Hi there, my name is Dr. Lakshara. I want to walk you through something I built called RepliCode. The problem it solves is simple to state but annoying in practice, which is like you read a research paper and you want to actually run the method, not just understand it, but see it work on real code or not. Most of the time, that means like hours of manually translating equations and pseudocode into a script, guessing at hyperparameters and debugging silently until it either runs out or you give up. So RepliCode automates that translation. You give it a research PDF and it produces verified executable Python code that implements the paper's method. And then it checks its own work before handing it back to you. As you can see now, I built this for two reasons to be specific. First is selfishly, like it's for a selfish reason. I want a tool that would let me get through the papers faster in my own learning, especially outside my core area, where reading alone doesn't tell me if I actually understood the method correctly or not. Second, I want a project that would force me to build a real multi-agent system end to end, not like a toy demo, but something with retrieval, the planning code, generation, and the self-correction, where I had to make real engineering trade-offs. So I'll just start with the demo. So first, you have to put in your uh, OpenAI key. On. There you go. And after that, you can upload the paper over here. Let's do that. I'm taking attention paper for now. It's for the transformers. So there are different chunking modes as well. Like for the speed, we have the full agentic mode, which directly use LLM, hybrid, offline, like simple split plus the LLM usage. Right now we are using just a hybrid. So the system is a multi-agent pipeline built on LangGraph, and it runs in 8 stages. There are 3 agents, each with a distinct job. So the planner reads the paper and breaks the method down into an implementation plan, what components need to exist, what order they need to be built, and what the inputs and the outputs of each piece should be. So you can just see what you want. So let's just generate the main methodology of the paper, which is transformers. So we'll just see. So next part, the second ager, the coder takes the plan. As you can see, there are different method summary, file plan, numerical claims, and planner notes. Blue scores for specific transform, which are used as claims. Okay, perfect. Now, so the coder takes the plan and actually writes the Python code over here. You can see there are different chunks and it generated the code. The critic, once it generates the code, the critic step, the critic plan, the agent reviews what the coder produced, checks it against the paper, and flags mistakes or gaps. Citations as well. So, for grounding the agents in the paper's actual content, rather than the model's rough memory of it, I built a hybrid retrieval layer. It combines ChromaDB for semantic vector search with BM25 for keyword search and merges the two using reciprocal rank fusion or RRF. That combination matters because papers often have exact terms and notation, variable names, equation labels that pure semantic search alone can't, like they can't handle, they tend to miss them. So you can just see over here and I explained before. So once the code is generated, it doesn't just get eyeballed, it runs. So I built a sandbox execution environment so the pipeline can actually execute the generated code, catch runtime errors, and feed those errors back into the refinement loop. So verified isn't a figure of speech here. The code has to actually run successfully before the pipeline calls it done. So when we execute it with refinement, so right now it's just executing with refinement and it's succeeded after 3 iterations. You can change the execution iterations over here as well. Right now the maximum is 5. I have kept as 3. That's the base one. And with that, you can see the quality matrix 0.09 overlap if you want to see word set overlap and outfit for next. Okay. And you can download the implementation once you're done. And as I explained, you can run the critic as well. So as I said, critic generates a report. Like the generator, it shows you the summary. As you can see, the generated code provides a simplified implementation of the transformer encoder architecture as described in the paper. And you can see the lexical overlap, the syntax is valid, executes, chunks use, it says as well. And yeah, that's it. So I've validated this methodology or the RepliCode on 2 papers with different characters. The one you already seen is the original 2017 Transformer paper, and a more recent paper is 2025 paper called Tab Region. Across both the pipeline hit like 6 out of 6. I'll just go to my README file. Over here is the all the code, the methodology, like how the code works. It all given. So it's a diagram is there. So once we get the PDF, we parse it, which chunk divided into the planner chunk set, and index it into 2 vector database like Chroma and BM25. Then the planner does once per paper, the coder loop, critic, and the evaluation matrix as in the form of faithfulness as we see. And these are the results which I was talking about. Yes, tab region, as you can see. So across both, the pipeline hit 6 out of 6 successful executions, meaning every core component it was asked to implement, it implemented and ran correctly. Along the way, I also had a bunch of like unambiguous but like real engineering problems, things like Windows path and encoding issues, dependency conflicts between protobuf and ChromaDB. So there like versions correctly for deployment as well. So not the interesting part of the project, but the part that determines whether it actually ships. Right now, this is just phase A, which is like the retrieval, the planning, the generation, and the verification pipeline I just walked through. So it's a fully working system on its own. The next phase is I'm working on is takes this further using reinforcement learning to actually fine tune the coding model on on this task. But that's a separate story, which I'll continue in the next upcoming videos. So that's it. That's RepliCode, where it turns a research paper into a code you can actually trust to run. Thank you.